We're in 2-2 today, but this is the activity that we did in class where the teacher like added some points to the test score. He added 5 points, and if you look, you know, like at the summary statistics, like there's only one thing that stayed the same. Besides, of course, the number of people that took the test. It was 20. Like that's what N stands for, is like how many people took the test. It was 20 both times, right? But didn't everything else besides standard deviation basically change? That's in the sheet, right? But check it out. Like if I was to just like highlight over this, it's like, didn't he add 5 points to the test score? So like watch me just like shift the graph 5 units left, right? To where like now the 85 is underneath the 80. Do those two graphs match like identically in that case? Like that's all that happened, is everything shifted 5 units right, because it's like, hey, he totally like added 5 points to every test score. So like what's weird, what you don't see on here is like the interquartile range. If you took that minus that, Q3 minus Q1, you'll get the same thing as that minus that, because both of them move 5 to the right, so it doesn't like affect the interquartile range or the range. And that's what today's lesson is all about, is like transformations of graphs. And I got it all filled out for us. Instead of us filling this out and taking a bunch of time, what you need to understand is how to use this graph, or this chart, I should say. There's 2 things that could happen. If you either add a constant, like this teacher just did, he added 5 to the test, or did you also see in the activity he multiplied, like he doubled everybody's, like some sort of multiplier. So there could possibly be a multiplier, and they just show us what changes and what does not change. So the easiest way to do it is to just dive in. I know it's really small now on screen, but that's why you have it in front of you. It's also kind of a reason why I have it on 2 pages, so you don't have to keep flipping back and forth. You know, you can see the chart and see this, and the chart will answer all the questions for you today, man. So here's the same thing. They say a teacher adds 5 points to each test score. Fill out the new summary statistics. So first let's do the shape, right? Here's the original guy. How would you say the shape of that is? Like fairly symmetric, skewed left, skewed right? Sorry, I used the highlighter. What would you think about that? That one would be what? I like it as skewed left. So the original guy's shape was that. They added 5 points to everybody's test score, right? So it shifted to the right a little bit, but did it change the shape at all? Is the shape still skewed left, right? So he is skewed left. And let's just kind of go see that in our chart. I have to use this part of the chart because we added or subtracted something to it, right? And you see how shape is right here, and it is in the category that says does not change. Would you be cool that if you add or subtract, like maybe they took 2 points away from everybody's test score because like there was just like a question that everyone cheated on and said we're getting rid of that, or you're getting penalized for it or something, but it doesn't change the shape if you add or subtract. Cool? And then here, let's go and just fill these out. Sorry that it's so tiny on screen, but X bar, not sure if we've ever seen that in this class. That's fancy math talk for the mean. So how does the mean get affected on this? We'll go find it in the chart. Does mean change or not change? Mean changes. You see everything on the left-hand side is under the category of changes. So we'll have to add however many points to the mean that they added to the test. Since they add 5, so we'll add 5. So how do you feel about 40.8? Do you see how I added that to 35.8? Again, sorry it's so tiny, but just trying to do all that. The standard deviation, change or not change? That's what this little S of X stands for, is standard deviation. Does he change or not change? Standard deviation does not change. Are you with me in the chart? It is right here. It is under does not change. So this standard deviation is 8.17. It will still be 8.17. And then the minimum, here they all are. All of the 5-number summary is under the min, the first quartile, the median, the third quartile, and the max. They're all under the change category, so you just add 5 to each one of them. Feel free to use a calculator if they're weird, right? But 12 plus 5, 17. Adding 5 to this, 37. Adding 5 to that will be 42, and then 46, and then 53. Cool. And these are different summary statistics than our applet shows us, because this one showed us the interquartile range and the range. We have to figure that out ourselves. Yes, sir. Right here. Add 5 to it. and get 40.8. Right, so cool. So does interquartile range change or not change according to this guy? What do you think? Interquartile range does not change. So since that was a 9, that will stay a 9. Same thing with range. Range does not change. The main thing today is look first, what did they do? Did they add? Sometimes it's subtract. Or did they multiply, right? Figure out which part of the chart you should be on. This one was an add question, so I went to that, and I just realized does it change or not change? Let's try that again here. The teacher changed their mind. They don't want to like add 5. They doubled every score, right? So how do you feel that that will put us in this category where they did multiplying? And honestly, I've done this enough times. Here's the trick. Can you just look and see how many things do not change? Like when you are multiplying, who does not change? The shape. Everything else will change. Everything else is a change on multiply. So how does it change? By whatever they did. They doubled, so you just go double everybody's score, right? So the mean, we need to double that. So 40.8, you just put that in the old calculator and take it times 2. How do you feel about 81.6 is what the new average would be on that? Everything just needs to double, right? So I'll let you do that real quick. Just pause the video and give that a shot. So I got it all filled out. Everything just doubled. The only thing that doesn't change is the shape. Here's our original shape. It's the same as before. It's skewed left. But the dots do change in the graph. It just spreads it out further, you know. But would you agree it is still skewed left, right? So it is not an identical graph. It has been stretched, you know, like twice as far apart, but it is still skewed left. Shape never changes. Shape's the only guy that's in both categories of does not change. So if you add, a lot of things change and a lot of things do not change. If you multiply, basically everything changes except for shape, right? How does it change? By whatever they did to it. So let's try again on the back side. That way you got your little chart side by side. So Miss Rita gave a 10-question multiple choice quiz to her 5th grade English students. The table shows the summary statistics. Here they tell you what she did. She decides to increase everyone's score by 1 point. You cool with where I found that? She's increasing. So what did she do? Add or multiply? Add. So we're using the left-hand side of this, right, to where we go and see who needs to change and who needs to stay the same. So here is the mean, and how do you feel that mean changes, right? How will it change? By however she did. She added 1. Are you with me on that? So we will add 1. So that would be a 9.25. Does that kind of make sense of where I'm getting these numbers from? Right? We're just changing it by that amount. The next thing is standard deviation. Standard deviation does not change, right? Does not change. So 1.9. Minimum, the whole 5-number summary is in there, right? Minimum, Q1, everything changes, so you just add 1 to everything. Why add 1? Because that's what she did to everybody's score, right? So you just do what they do. If it says change, it's like she increased by 1, I'll increase everything by 1. Are we okay with that move? And then it's time for the Pitbull question of the day. Excuse me, Mr. Worldwide. He gave a quiz to his class. The table shows the summary statistics. He decided to triple everyone's score. Due to the difficulty of the quiz, fill out the new summary statistics. So triple means we are right here, my friends. So everything changes except for shape. How does it change? By whatever he did. Triple, that means times 3, right? So take everything times 3. 6.9 times 3. Sorry, I'm doing this off-screen calculator, people. So 20.7, 1.9 times 3, 5.7, 12, 5.5 times 3, 16.5, times 3, 19.5, times 3, 25.5, and 30. I like the multiply ones, right? You don't have to think too hard because everything changes, you know. To add ones, you have to go and see. Here's how it really works on the add ones, to be very, very specific with you. These are all measures of center right here, your mean, your median, your mode, and these are all measures of variability, or we call spread, like how far apart they are, right? So those, like the measures of center always change, and the measures of spread stay the same when you add or subtract a guy. Cool. I think there's just one more left. Is that right? Yep. So suppose you calculate all this junk, the range, the standard deviation, and interquartile range of a data set, and you got it here. Boom, boom, boom. Your main job is to go read and see what they did. Did they add or did they multiply, right? You got to go see what they did. And can you tell right here, they say they add 10 to every value in the data set, right? So on your charts, you'd be using the add section and realize if these things need to change or if they stay the same. So we're talking about range, standard deviation, and interquartile range. Well, look at these bad boys. Range, standard deviation, interquartile range, they stay the same, right? They do not change. So 30, 3, and 2. But what happened to the shape of that bad boy? If they add 10, what should happen to the shape? Should it change, stay the same, or not enough info to tell? It should stay the same. Not too bad. Basically got her done in 12 minutes today, right? So let us know if you have any questions. Have a good one.